All right, class. In this lesson, you're going to learn to multiply and divide rational expressions. So let's go ahead and get started. All right, before we start with rational expressions, let's review how we would simplify this particular fraction. Okay, so normally what we do is we would find common factors of 12 and 16 and eliminate those because they become 1. So here we want to look at what are the factors of 12. Well, it is 3 times 4, and the factors of 16 are 4 times 4. Okay, now 4 can be further factored into 2 times 2, so we can go ahead and do that, and that becomes 3 times 2 times 2 divided by 2 times 2 times 2 times 2. Okay, so what we've done essentially is prime factorization, or factoring it down to its prime numbers. So if we take a look at what's in the numerator and the denominator, we see that there are 2 2's in the numerator and we have 2 2's in the denominator. Okay, and because we have those, we can go ahead and eliminate those. 1 on top, 1 on the bottom, and another 1 on top and down at the bottom. And so this simplifies down to 3/4. Okay, so this process that we just went through is going to be very similar to simplifying rational expressions. So let's take a look at the next example. All right. Here, what we want to do first, like we normally do with any polynomials, is find the greatest common factor. Okay, and when we do, what we end up with is x times x squared minus 5x minus 24 in the numerator, and in the denominator, the greatest common factor is also x, so we can factor that out, and we get x times x squared plus x minus 72. Okay, so across the numerator, the greatest common factor is x, so we took that out, and across the denominator, the greatest common factor was also x, so we factor that out. Okay, now what we want to do is focus in on what's inside the parentheses in the numerator and the denominator. So let's go ahead and focus on the numerator first. Okay, x squared minus 5x minus 24. Okay, so at this point, you should be able to recognize that this polynomial inside the parentheses is factorable. Okay, and the way to do this, or one way to do this, I know there are multiple methods, but I believe that the simplest way is to look at the factors of negative 24 such that when you add them together, you get a negative 5. Okay, factors of negative 24 such that when you add them together, you get a negative 5. So let's take a look. Off to the side, I'm going to write negative 24, and we're going to look at all of the different factors. Okay, so 1 and negative 24 are factors. Negative 1, positive 24 are factors. 6 and negative 4 is also another factor, and negative 6, positive 4 is a factor. Then we also have 2 and negative 12, and negative 2 and positive 12. And then lastly, we have 3 and negative 8, and negative 3 and 8. Okay, so these are all of the factors of negative 24. And the key is to find one such that when you add them together, their difference comes out to negative 5. Okay, that's what this middle term is. So let's go ahead and add them all together. And when we do, we see that the first pair comes out to negative 23. So that's not the correct answer. The next one is a positive 23. That doesn't work. The next one comes out to positive 2, and the next one comes out to negative 2. So that's not what we're looking for. 2 plus negative 12 is negative 10, and negative 2 plus 12 is positive 10, so that's not it either. The next one is negative 5, which is exactly what we're looking for, and the last one is 5. Okay, so what we'll see is this is what we're looking for. Okay, in other words, 3 times negative 8 is a factor of negative 24, and the sum of them gives us a negative 5, which is the middle term that we're looking for. Okay, so then this comes out to x times, and I always like to set it up with 2 sets of parentheses and starting with an x for each one of those, and then all we do is enter positive 3 and negative 8 as our answer. So we have positive 3 and negative 8. Okay, so that is factored. So that is this, what I've written off to the side is the process that needs to go through mentally to factor any polynomial that is factorable. Okay, so for this denominator inside the parentheses, you need to be thinking about factors of negative 72 such that when you add them together, you get a positive 1. Okay, so what we find is that the factors of negative 72, which when added together give you a positive 1, are 9 and negative 8. Okay, so we start off with x's in each one of the parentheses, and we said that the factors are positive 9 and negative 8. Okay, so 9 times negative 8 gives us negative 72, and 9 plus negative 8 gives us a positive 1. Okay, so continuing on with simplifying this rational expression, you see that we have an x up here and x down here, and so we can go ahead and cancel those because they come out to 1, and then we have an x minus 8 and an x minus 8 down here, and so we can cancel those, and so my final answer is x plus 3 over x plus 9. Okay, now the one other thing that we need to recognize is that we need to find values of x such that when you multiply them out, they end up becoming 0. So for example, if x is equal to 0, okay, if this is 0, then this whole denominator ends up being 0, and that ends up becoming an irrational number. Okay, and so therefore x cannot equal 0. That is not a possible domain for this entire expression. Okay, and then the other value of x is negative 9, and we would say negative 9 because negative 9 plus 9 gives us a value of 0, and when this becomes 0, the entire denominator ends up becoming 0. Okay, so x cannot equal negative 9, and lastly, x cannot also be 8 because 8 minus 8 gives us 0, which means that this ends up becoming a 0 in the denominator. Okay, so then we would say that the answer here is x plus 3 over x plus 9, where x does not equal 0, 8, or negative 9. Okay, so it's important that when you are simplifying rational expressions that you also indicate what the possible domains here are. So this would be all domains. Domains would be all real numbers except for x equal to 0, 8, and negative 9. They cannot equal those values. Okay, let's move on to the next example. Okay, so let's go ahead and simplify this. The first thing to do is to focus on the numerator. Okay, and we see that this is a perfect square difference of perfect square binomials, and so this could actually factor out to 2 plus x times 2 minus x in the numerator. Okay, and then the denominator, we'll see that it is factorable in that we would find factors of negative 10 such that when you add them together, you get a positive 3, and that would be positive 5 and negative 2. Okay, so we would put positive 5 and negative 2. Okay, now in this situation, it is not super clear that we can eliminate anything in the numerator as well as the denominator. But what we do notice is that 2 minus x and x minus 2 are fairly close, okay? And so what we need to do is that we need to factor out a negative 1 in this case. So when we factor out a negative 1, I'm going to go ahead and just rewrite this. Oops. Rewrite the numerator. Now we're going to factor out a negative 1. And when we do, this 2 minus x ends up becoming x minus 2. Okay? Now, if you were to reverse the operation, if you were to multiply these two together, you'd see that negative 1 times x becomes negative x, which is what this is, and negative 1 times negative 2 is a positive 2, which is what this is. Okay? All right, and then in the denominator, we'll keep everything as is. And so now we would recognize that x minus 2 can be canceled out because we have 1 at the top and 1 at the bottom. So we would go ahead and cancel that out. And then our final answer would be, and I'm going to go ahead and multiply this out here, that becomes negative 2 minus x over x plus 5. Okay, and now we have to specify what the domain is, or what x values cannot be. So we're going to say where x does not equal to negative 5 or 2, okay? Because both of those x values would make this denominator 0, and that would not be valid in this case, okay? So then we would say that this is our entire answer. Okay, let's move on to example 3. Okay, so now we're going to be multiplying rational expressions. And here, what we want to do is very similar to multiplying fractions, in that we would multiply across the numerator and then across the denominator. Okay, so then this would equal 6x cubed y over 4yz squared. Okay, now we could have canceled some things earlier, but I'm going to go ahead and just do it right here. So if you take a look, we have a y in the numerator and a y in the denominator, so those can get canceled out. Okay, we have an x up here, we have no x's down here, so that nothing we can do there. We have a z down here, no z up here, so there's nothing we can do there. But we can reduce this. Common factor is 2, right? 2 times 3 is 6. 2 times 2 is 4. The common factor is 2, so we can take that out. And so we would go ahead and rewrite this as 3x cubed over 2z squared. Okay. Now, the one thing that we have to recognize is the domain, possible domains. And z cannot equal 0, y cannot equal 0. So we would say that the answer is 3x cubed over 2z squared, where z does not equal 0 and y does not equal 0. Okay, so that is our answer for this example. Okay, and moving on. Here we've got a bunch of polynomials, okay, and we shouldn't let this throw us off. But before we multiply across the numerator and across the denominator, we should probably simplify, otherwise this will get very complex. Okay, so we would say that this is equal to 5x, okay, over x plus 3 times, and then you should be able to recognize that this polynomial is factorable. And if you think about factors of -6, such that when you add them together, you get a +1, the solution would be +3 times -2. Okay, so then this comes out to x plus 3 times x minus 2. And then looking at the denominator, we would factor that as well. Okay, and what does that factor out to? Well, the factors of 1 are 1 and 1, and when you add those together, that gives us 2. So we would have an x plus 1 and an x plus 1 down here. And then lastly, we would factor this, and we'd see that there's the greatest common factor of x, so we'd factor that out, and we would get x times x plus 1 divided by, and then down in the denominator, we'd find that the greatest common factor is a 5, and so we factor that out, and we get 5 times x minus 2. Okay? So now what we would do is start canceling things. We see that there's a 5 up here and a 5 down here, so we would cancel those. We have an x plus 3 up here, an x plus 3 down here, so we'd go ahead and cancel those. And we also have an x plus 1 here and an x plus 1 here, and we would cancel those. And lastly, we have an x minus 2 and an x minus 2. We would knock those out. Okay, and so what we have left is x and an x, and so that becomes x squared. X times x is x squared over x plus 1. Okay, now the last step is to specify the domain, or what x cannot equal, and so we would say that where x does not equal -3, right? So this makes it 0, -1, and 2. So we'd say x does not equal to -3, -1, and 2. Okay, and that would be our answer for this example. Okay, moving on to the last example. I'm sorry, second to last example. Here we are multiplying a rational expression by a polynomial. Okay, and so this one is very similar to the previous example in that we want to factor this and factor that. Okay, so the way we would do this is the first part would be x plus 2 over, now look, difference is perfect square. This becomes factorable to x squared minus 4 times x squared plus 4. Okay, and then for this polynomial expression, we'd find the greatest common factor, and that is x, and so we'd factor that out. So we'd say that this is x times x squared plus 4x minus 12. Okay, now we would also need to factor the polynomial inside this parentheses, and we would also, or at least should recognize that we can factor this further. This is a difference of perfect squares. All right, so this becomes x plus 2 over x plus 2 times x minus 2, which are the factors of x squared minus 4. That nothing we can do with the next one, so we go ahead and write x squared plus 4 times x times, and you should recognize that the polynomial in this parentheses is factorable. Difference, the factors of -12, such that when you add them together, we get a positive 4, or 6 and -2. Okay, so it would be positive 6 and -2. All right, so now that we have all of this factored out, we can start canceling things. We have an x plus 2 here, an x plus 2 down here, and so we can cancel those out. And we have an x minus 2 over here and an x minus 2 down here, and so we can cancel that out. And then what's remaining is x times x plus 6 over x squared plus 4. Okay, and then the last step is to identify the domain. So where x cannot equal -2 and positive 2. Okay, and here -2 and positive 2 don't matter here, and there's nothing here that will make this 0 other than an imaginary number, and so we don't have to worry about that. We're only looking at the real number world, and so we would say that where x is not equal to -2 or 2. Okay? And this is our answer for this example.